So here's the second example. Well, what happens if you do have a triangle and it's actually a right triangle, meaning you don't even need the law of sines, which is really, really important. So what I'm talking about visually here is what if this altitude, which you don't know where it is, it swings in and hits at one exact spot, and that spot is right. And so you don't know if this visual is happening until you look at that contained side and what its comparison is to the altitude. So notice in this problem, I mixed up the labeling. I labeled it B. B, in this diagram that you're looking at, this would be B. The contained side would be here. The altitude, which we don't know is the altitude, would be here. And then this would be whatever it is. I labeled it A just to make sure kids could label it correctly. But you don't really need to worry about what any of this is labeled. You need to worry about putting this angle on the left, whatever's across from it, and whatever you have left, put it above it in between those two things so that you have side, side, and then angle. Again, that's what's critical. So let's take a look at this particular drawing with this information. So what I did in this problem is I put that B right there, put the 30 there, opposite of it is the 5, and then between those would be 10. Again, side, side, angle. And I found the altitude the way you've been used to finding altitudes by doing sine is opposite of hypotenuse, so sine is altitude over 10. And of course, you solve this by just multiplying by 10. And again, if you have been doing this since the beginning of the assignment with area of triangles, it becomes pretty routine. And so altitude is 10 sine 30. So then we have to realize then that the altitude is equal to 5. You can type it in the calculator, 10 sine of 30 is 5. And the first analogy is, okay, well, that altitude is exactly the same as the contained side. It's not less than, it's not equal, it's not greater than, it is equal to. And this means that we just have a leg of a right triangle. The altitude is actually the leg of a right triangle. We had no idea. And so when we just redraw it, what we're going to do is we're going to take this picture that we drew, which was the wrong drawing, but we didn't know, and we redraw it with that being right there. So this picture was off. It's actually, that 5 is there. So we just redraw the picture with the 5 being the side of the right triangle, finding this angle C by doing the angle sum theorem, getting 60 degrees. And after we redraw that, if I want to solve the triangle, it's pretty easy to do. Remember, if you have no triangle, you're done. But if you have a right triangle or any other example, you have to actually do the problem. So now we're just going to go back to the very beginning of what we learned in trig. If I want to find, I'm going to write down what we have. We have angle B is 30 degrees. We know that angle A is 90 because it's a right triangle, because we discovered that through the altitude. We used the angle sum theorem and subtracted to get that the other angle was 60. Then we were also given A and B were 10 and 5, so the only thing we have to find is side C. There's a lot of ways to do it. I'm going to use 30 in the given information, just in case I did anything wrong. So with the given information, this is opposite, and this would actually be adjacent, right? So I'm going to do opposite over adjacent, which is tangent. Tangent of 5 over C, you would just simply multiply both sides by C, giving you C tangent 30 is 5. You would then divide by tangent of 30. Remember your algebra skills in trig. And then you get the only answer you actually had to find using trig in this problem, which is 5 over tan 30, which if you type in the calculator is 8.600. Then double check to see if there's any units, which in this problem there were not. So we can leave it like that. So just a recap, you don't know what you get with side, side angle. We were given at the beginning side, side angle. You don't know what you get, so you have to find the altitude and then reevaluate what you think you have from there. And then once I realized in this case that I had the altitude as actually the side, they're equal, then I drew a right triangle and corrected my mistake that I didn't know that I had until at that point. And then I put in what was given, and then I found the only side missing, which was C, using just regular right angle trig. Because in this problem, it was a right triangle.